In this video, we're going to talk about how to build a binary expression tree from Postfix. So, for example, you would be given something like parentheses 5 plus 2 times 8 parentheses minus 3. So when you're building a tree from Postfix, if your token is the following, you have an operand. Your operand is going to make you instantly create a node, and then you're going to push. When you have an operator, that's going to make you pop the left subtree, or you're going to pop the right subtree, then you're going to pop the left subtree, pop the right subtree, then you pop your left subtree, then you create an operator node, create your operator node. After that, you attach your left and right, attach your left and right. Then you push the new subtree, push your new subtree. So that's what we've seen when we deal with those stacks. So when you have this expression here, our postfix is going to be 5 to 8 times plus 3 minus. So how are we going to evaluate this? When you see your 5, what you're going to think is, oh, this is an operand. So then you're going to create a node 5. And then that's going to push. So each item in the stack is a subtree. That's something to note. And while we're doing this, I'll actually draw along the tree so we can see how this looks like. So here are your stack. So you're going to push your 5. And then after this, you see that you have the 2. So this is an operand. And then you're going to create a node 5 or a 2, and then you're going to push that. So your 2 is going to go on the stack. Again, you see you have a operand 8. So that's going to create a node 8, and then you're going to push that. So this is outlining the process of when are each of the nodes in the tree created while we do this evaluation. 8. And then we see our times. This is an operator. So because it's an operator, you're going to pop twice. So then you're going to pop your left and your right. You're going to pop your right, which is on top. And then this is going to be your left, which is lower. So now it's going to create a node times. And then you're going to attach this. So from this, you're creating, actually I want to see like 8 to, you have 8. I meant to write 5. So right here, what you have is your 2 times 8 here. That's what your expression is. And then your subtree is going to be times 2, 8. And you push the subtree. So right now on your stack, you can actually write 2 times 8 if you wanted to. So now you have 2 times 8, but you could also just write the result of this. 2 times 8 is what? 2 times 8 is just going to be 16. So you could also just write 16 on here, but some people like to write the parentheses. But I'll just write the parentheses to show the work here. After that, you have 5. You have plus. Plus is an operator. Because it's an operator, you're going to pop twice. So you're going to have a node created of plus. But let's look here on our stack. Right now, you're going to pop your right, which is this. And then you're going to pop your left, which is this. So now you're going to attach this. Push this. And attach. I want to write that there here too. And attach. So you're going to attach this. You're going to have plus 5 times 2, 8. And now on your stack, we're going to add this. So this is going to go 5 plus 2 times 8 onto the stack. So that's on top of here. So the expression for this was 5 plus 2 times 8, aka 16. If that makes things easier, it kind of does, but yeah. So after this, we are going to look at our next thing. We have 3, simply is an operand. So you're going to make a node of 3, and you're going to push that. So the node creation is just a 3, and your 3 is just going to add onto this stack here. And after this, we have a minus. So you're going to do minus. This is an operand, or operator. And that's going to be a node of minus, and you're going to push and attach this subtree that it creates. And attach, what you want to attach is going to be your minus plus 5 times 2, 8. And you have a 3 over here. So that's your full tree. And you're gonna have to pop the left and the right. So let's show how we did that. So your 3, that was gonna be your right, and then your left is gonna be this. So yeah, and then you push that full tree onto the stack. So now that's just your full tree, aka like this. Well, this is gonna be on top of your stack. So the result of all of that. So that would be the result of that. Yeah. So overall, what we see that like Postfix can guarantee for us is that operands come before the operator. Operands come before your operator. So when you have an operator, the two operands needed must already be on the stack. Already be on the stack. So remember, don't pop left before right, and also you always have to add this subtree back. Always re-add your subtree because you have to get the final tree. And also remember, the tree nodes, they hold subtree. Like, for example, all of these operators, they have, as you get like higher, they all have a subtree in them. So always one value at the top. If not, it's invalid. So